is that when something disappears into the distance, you can see it again when you zoom in. And while this is true to a certain point, it doesn't apply to things below the horizon, which, as the buildings get bigger as you zoom in, but notably, you can never see more or even less of them. You can simply resolve them better because of the magnifications. The bottoms of the buildings are still obscured.
Which is a pretty good response by this somewhat offensive guy.
Never laugh so goddamn hard. Keep it up.
But the facts of the matter.
What is it with people talking like this?
Some facts, do you?
Where did this start? Was it something from film?
I'm sure they aren't going to be childish misrepresentations of reality based on a tiny perspective and a lack of any scientific education. No.
It is a fact, not a theory, that bodies of water always seek and find their own level.
Seriously, is this guy trying to be a cliched cult? Does that work?
Of being corrected about how wrong you are all the time. You know, what about... No, do you know what? I'm going to let you continue for a bit. Otherwise, I'm just going to end up repeating myself even more than I'm already going to.
Inevitably going to end up repeating yourself. But let me just get something here. Something I think might...
And find their own level.
Wait for it.
Oh, God, this one again. Do you guys ever get sick of being corrected about how wrong you are all the time? You know, what
This
about...
one, there was a...
No, do you know what? I'm going to let you continue for a bit. Otherwise, I'm just going to end up repeating myself even more than I'm already going to. After having addressed this point countless times in countless ways.
There we go. That was the one that made me get the camera out. Print screen. Gimp. Paste. And I hope I don't have any porn open in any of the other tabs. That would be very embarrassing. Pretty sure I don't. Crop that. Zoom in a little. And let's just go from that pixel all the way across. That's awkward because it isn't level. Not quite level, so that doesn't exactly work. Just to measure a straight line across it and say, hey look, the horizon's above the line here, parallel with it, and it tapers down to it there. But there's a trick Anne, I think, showed me. Showed us all. Image, scale, decouple the X and Y axes, and shrink it horizontally. Dink. Wow, that is ugly. If I then zoom in, does that look kind of curved? Just there? Just ever so slightly? Let's get rid of that. Let's get rid of that and go back to this video. This guy is tearing to pieces. And find another image. No, that's one that he's showing.
From a pond, lake, or an ocean.
The matter there. Don't want to leave them up long enough for me to take screenshots in case I do that again. Let's try again. All these flashing green lights. I swear it's meant to be some kind of hypnosis. Let's go for just the relevant part. Just across there. Crop. Zoom in. Scale. Couple it again. 1 to 8. Got the exact same width twice in a row. Impressive. Can we even see the horizon on that? Well, it's not right obvious. It's not really clear enough to see on there. It's annoying. Let's just do that.
pond.
Oh, that's no use. That one. Let's try that one. Print screen. Drop out full screen. Paste. Rectangle. Rectangle select from that edge. Very slightly dip down there. Scale it down from 1920 to 96. Wrong. Decouple and scale down to 96. And then get rid of that. Zoom in. Perfectly level? Doesn't look perfectly level to me. It looks that shape to me. That's curved. It's good. 3 for 3 so far. Or was that 2 for 3? Or 3 for 4?
Or an ocean.
Let's count. So many idiots.
Water is defined and remain
This guy is really, really annoying.
level.
It's like the bullshit artist,
Okay,
you know.
let's take a look at a
James
large
Bond
body
film or
of
something,
water
you
with
know.
a reference point, so that we can see what water does with enough space to affect either a curve or a completely flat surface. This is the little tensor Bayou.
And this is a
I want you to
freaking
pay attention
curve.
to that high
Yes.
watermark. If we follow it along, you
Find me
can see
another
that
picture of
it
it. There we go. Oh, come on. A picture with the horizon barely visible, that's cheating.
Level water, thus making it an unscientific theory.
Yeah.
an extremely cool graphic. Something I've got to give you props for, by the way. It absolutely shows you have no frigging idea what you're talking about. Again
Yep.
and again. Gravity.
Gravity, you retard. Never mind. More shaky cam footage. Let's try to get some actual... Here we go. It's another picture of... Ah, that's his picture, isn't it? His zoomed in picture across Lake Michigan. Michigan looking at Chicago, or is it across Lake Ontario looking at Toronto? Whichever one it is. Back to there. Paste. And this time, it's very definitely not level. Measure the angle from there to there. Actually, it does look like this one's almost drawn a straight line. That angle is 0.81 degrees. Rotate the whole damn thing that way. 0.81 degrees to level the horizon, and then scale, decouple them, scale down to 96, just a nice 1 in 20. Do that. Somehow it turns out not to have levelled the horizon. But again, it doesn't quite look like a straight line, it looks curved. It's this funny thing where anytime you can see clearly enough to see what shape it is, it turns out to be curved. It's weird.
It again when you zoom in, and while this is true to a certain point, it doesn't apply to things below the horizon.
Oh god, this one again.
It is a necessary theory that the globe Earth must curve 8 inches per mile squared if it really be a ball.
Right, that one just keeps getting quoted and quoted and quoted, and it hasn't stopped being bullshit. So, find some space on a table. We've got graph paper here. It's handy stuff, graph paper. Lets you draw graphs. Down there. In between the legs of this here tripod. That's visible. That's visible-ish. Be able to see that. Right, slide that off. Don't need that, so we shall have it off. Got a ruler. Can do this. 8 inches per mile squared. That's not even a mathematical expression. No. But I know what they mean. And what they mean is that y equals 8 inches times, open brackets, x over 1 mile, close brackets, squared. Which is y is a constant times x squared. And a graph of y equals x squared you can look up on Google. Or I can draw it for you because I'm feeling generous. On the x-axis, 0, 1, 2, 3, 4, 5. I'll have -1 here and -2, -3 and -4. 0 squared is 0. 1 squared is 1. -1 squared is also 1. 2 squared and -2 squared are both 4. 3 squared is 9, -3 squared is 9. 4 squared is 16, -4 squared is 16. 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and 9 squared is 81. That'll fit. It does fit. 9 squared is 81. And what you get is a symmetrical curve through all of those points, like that. Off to infinity at both sides. Now you can label this with whatever numbers you like. If that's 1 mile, then that's 8 inches, that's 16, 24, 32, and that's the formula he's just given you. You could also call this 100 miles, and this would be 80,000 inches, 160,000 inches, 240,000 inches, 320,000 inches. It's the exact same shape, because that is y equals x squared. It's just, that's the shape that formula gives, and changing the constants just scales the axes. It doesn't change the shape, it just stretches it one way or another. Now, what do you say? The third problem with this? Yeah, the third problem is that it's an approximation. It's going to get less and less accurate. In particular, the third problem or the second? Yeah, the third problem. Let's call it the third problem. You've got a curve where we're saying that y equals, now it is 8 inches divided by, 8 inches times x over 1 mile squared, which is 8 inches times x squared per square mile. And 8 inches per square mile is 8 inches divided by a square mile is the length of a strip of paper 8 inches wide that covers a square mile. Just to give that some kind of meaning. Which would be 8 divided by 63,360 squared. Or 1.99278 times 10 to the minus 9. So there's going to be a point at which squared, which x is the reciprocal of that. The reciprocal of that is 501,811,200 inches. At that point, that number squared times that is just that number, 501 million. So y equals x. 501 million divided by 63360 is 7,920. Exactly. 7,920 miles away, according to that formula. The object you are looking at, if you're standing on top of the Earth, looking across, the object you're looking at that distance away, if we put this in thousands of miles, somewhere here is, I was going really wrong, down there. It's actually as far below the horizon as it is away from you, which doesn't make a right lot of sense. You can go worse than this with a quick Google search. Type that with two hands. That number right there, 40075 kilometers in miles, 24901. Bring up the calculator. 24901 squared times 8 is that many inches. 4960. It's a big number, isn't it? 496 million inches. 496 million inches in miles is 7,828 miles. Diameter of the Earth, that's funny, it doesn't have miles, but in miles. Diameter of the Earth in miles, 7,917. So according to this formula, I forgot to halve it, didn't I? Oh, bollocks, never mind. Let me try that again. God, let me try that again. Right. Go back to the circumference of the Earth. 40,075 kilometres. 40075 kilometres divided by 2 in inches. Slightly smaller number, 788. Well, 789 million inches. 788877953. 788777953. Supposed to square it, wasn't I? Supposed to square it. Times 20037.5, that's, you know, half of it. that's squared. And of course, I'll tell you what, how about I just brain like I've got a brain. It's half of it. Squared times 8. That's the number I want. 3212011250. 3212011250. 0 inches in miles. 50,694.622 miles. There you go. Is it going to work? No, it isn't. Oh well. Still, you know, 50,000 divided by 8,000, there's a pretty obvious problem, right? How far it should be below the horizon is several times the diameter of the Earth. You can see how this might be considered a flaw in a model for where something is. Yeah, that will be problem number 3. Problem number 2, put that away again, and grab my slightly larger picture. Just slightly. It's this thing again. This thing. Sorry, that's the lens. This picture of a curved Earth with volcanoes. There you go. Huge volcano relative to the curvature of the Earth. I will put the pencil down out of reach. This is a terribly badly planned video. It's got my feet in it now. Anyway, if you are standing at phenomenal height here, that stupid damn 8" per mile thing is supposed to tell you how far down the horizon is. Let me get this back. But it's how far down from that line. It's supposed to be telling you this distance here. Whereas you're not looking along that line because your eyes aren't on your toes. If you're a kilometre tall, you're looking along that line. So the distance is even greater, but that's if you're looking horizontal. If you've levelled a theodolite and you're sighting through it. If you're looking at an object in the distance, you're looking down. And how far you can see skims the horizon and comes off all the way down here. So you can easily see things that are a heck of a long way below the distance that that silly formula tells you that the land is below the horizon. Because it's not calculating for the horizon, it's calculating for level with your feet. Yes. That is the second problem with our 8" per mile. And the first problem with the 8 inches per mile thing, to tell you how curved the Earth is over a certain distance, is that this shape right here is not a fucking circle.